All right, welcome back. Here we are on the second page of the practice test for the second unit test. Factoring. Factor each of the following binomial expressions to create an equivalent expression. To receive full credit, you must use the GCF. All right, so I've already gone ahead and written in the GCF. We'll talk about them a little bit in a couple of spots as we go. But just to save time, I've already calculated the GCF for each of the terms in each problem. So if you are unclear on how I'm getting those, definitely make sure you brush up on or come in and get some help or practice with finding the greatest common factor. Okay, so the Lamphere method for this is once you figure out the GCF, that's our magic multiplier. So if we can chop just like we chop for combining like terms. Let me chop that a little better. And then you're just dividing each term by this common factor. You're factoring it out. So whereas this was 10x, if I divide it by 5, I have 2x. This is a positive 15 divided by 5. That's 3. And by factoring it out, what we're doing is taking essentially the reverse of the distributive property. So I'm thinking, what number do I have to multiply by 5 to get 10x? Well, it's 2x. 5 times 2x is 10x. What would I have to multiply by 5 to get 15? 5 times 3 is 15. So the way that we get these terms on the inside easily is to chop it up and divide by that common factor. And in this case, we need the GCF. So for this one, the GCF was 11. I'll chop it right here, and I'll just think of this as two separate questions. What's 22x divided by 11? And what's 55 divided by 11? Since 55 divided by 11 is positive 5, we just write a plus sign here. And then you can always check by doing the distributive property. Make sure you end up back at the original. All right, let's do the next one. We're going to divide this or chop it up and then divide by the GCF of 9. 9x divided by 9 is 1x. So I'm just going to write x. If you put a 1 in here, that's okay for now. And then when we get to this one, notice that now this is a negative 27 divided by a positive 9. Negative divided by positive is negative, so I call that minus, and 27 divided by 9 is 3. Now, this one's a little bit interesting because it starts with the negative 3 on the outside. So since the coefficient was negative, I chose to start with a negative GCF. So the GCF of 3 and 15 is 3. But since the coefficient was negative, I said, let's factor out the negative as well. So we're going to divide by negative 3. Whatever number you put in this GCF spot, that's what you divide by. So negative 3x divided by negative 3 is positive 1x. And again, you don't really need the 1. If you put it in there, that's fine. I'm just going to call this x. And now to the second term here, 15 divided by negative 3 is a negative 5. Now, what if you decided to use positive 3? I would still count this absolutely, but now if we divide by a positive 3, the signs on the inside have to change. These are also equivalent. And we know that because if we distribute, we end up back where we started. So I would accept either way. And even on these up here, if you decided to factor out a negative for some reason, I suppose I would count it. For right now, I'm just going to stick with the idea of if it starts with a negative coefficient, let's factor out the negative as well. So let's do these last couple of this section. Divide this by negative 6. You get positive 3x. Divide this term by a negative 6. You get a negative 4. So we write minus 4. Writing it the other way around, if you had divided by a positive 6, everything on the inside switches signs. Our negative 20 is our GCF here, so we're going to divide this by negative 20. And often in slightly more advanced math, you like to factor out negatives. Sometimes it's really nice to get the negative out of your problem. And one way to do that might be to pull it out as a common factor. So it makes a little bit of sense here to divide by the negative GCF. Anyway, so let's stick with that. We're going to take negative 20x divided by negative 20 is a positive 1x, and a negative 80 divided by a negative 20 is a positive 4. If you want to see what it would be if you had gone the other way, if you took the positive 20, then you'd need a negative x and a negative 4 on the inside. Okay, that's it for that section. Ideally, on the unit test, your work would look a lot like mine. You're chopping it up, you're showing the divided by, and you're double checking. It really is not a race. So doing these without the method is probably not advisable. Take your time, use what you've been taught. It works. All right, finally, a combination of these things. It says, for each of the following problems, first, apply the distributive property where appropriate, and then combine like terms to get a simplified expression. And then this is important. Following directions is important here. Circle or put a box around your final simplified answer. So I want to see your work, but I also want to be able to quickly identify what the final answer is. So on this problem, I'm going to circle this because it's being distributed. I'm not going to circle this minus 10 because it has nothing to do with the distributive property right now. The distributive property is super powerful, but it can only go as far as the parentheses go. So negative 4 times 5x is negative 20x. A negative 4 times a positive 2 is a negative 8, so I write minus 8. And I haven't done anything with this part of the expression, so I'm just going to bring these down. I still have the 3x, and I still have the minus 10. Let's chop that up. Chop to the left of the sign. And then let's combine like terms. Negative 20x plus 3 is negative 17x. Negative 8 minus 10 more puts you at negative 18. And remember, I'm not done yet. I need to circle or put a box around this. It's super important all throughout school and life to follow directions. So when you get done with your unit test, you might go back and double check the directions. Did I remember to circle or put a box around it? It might seem silly to lose a point for that, but following directions is such an important part of demonstrating understanding that it's silly to lose a point for that as well. Right? So it might seem silly that I'm taking a point off, but it might seem even sillier on your own to not follow the direction and take your time to double check. So just be careful of that. All right, let's look at the next one. If I am going to distribute before I solve, this is a positive 3 being distributed to this and to this. Notice it can't reach all the way over to this. That 3 doesn't go with this. This is totally separate. So I'm going to bring the 5 down. I haven't done anything with that yet. I'm going to trade in this as 3 times 8x is 24x. I take 3 of these negative 9s. That's the same as subtracting 27. And then I haven't done anything with the minus 6x yet, so just bring that down. Chop it up. Chop to the left of the sign. Let's see, I'll use purple this time. Here's my x variable term. Here's another x variable term. 24 minus 6 is 18. Don't forget the x. And then our constants goes 5 minus 27. If you're at 5, but you lose 27, now you're at negative 22. Again, you have a calculator. I would definitely double check these calculations. What do I mean by that? I mean, if you get it to this point even, literally type into your calculator 5 minus 27. And make sure you have the right thing here. Last one. What I want you to think about on this one is this 14x has nothing to do with the distributive property. So what we're really doing here is we're saying, I want to take away this, and I want to take away that. So I'm going to bring down the 14x because that has nothing to do with the distributive property. I haven't done anything involving the 14x yet, so it just comes on down. And then this is minus 7x plus 11. I distribute that negative sign to each of these, or like we talked about earlier, if you want to distribute this as a -1, I'm fine with that. Chop it up and combine your like terms. 14x minus 7x is 7x. Our constant term has nothing to combine with, so we just bring that along. And I don't want to lose a point, so I'm going to make sure I put either a circle or a box around this. So the last words of advice I have. Follow all directions, use what you've been taught. Don't try to do everything in your head. And then when you have something that is a negative, make sure it's obvious. What I don't want to see is like a case where Mr. Lamphere has to try to figure out if you actually have the negative sign or you don't. Make sure things are clear and easy to read. Then when you get done with the entire test, there's no prize for being first. So you might as well take your time, go back, double check everything, check your signs, make sure you made the answers clear. If you were supposed to circle, you circled or put a box around your answers. All of that stuff is stuff you could check. We've had people skip entire questions that I know if they had gone back and double checked, they'd be like, oh, I didn't do question 18. Oops. And then they go ahead and do it. So you want to make sure you check before you turn in your paper. That's it for this video. Thanks for listening. If you need help, you know how to reach me.